Today I'm going to tell you about the uses of hexadecimal system. Hexadecimal system comprises of digits from 0 to 9, and then the alphabets A, B, C, D, E and F are also parts of hexadecimal system. Now I'm going to tell you where the hexadecimal system is used inside the computer. The first use of hexadecimal system is in the error codes. The locations inside our memories are written in the form of hexadecimal number system. So if there is if an error occurs somewhere inside your hard disk, that error is shown to you on the screen with its address, with its location. So it becomes easier for you to find out the error in your inside the computer or in your file, if you know the location and the detail of the error. So any person who is literate about the hexadecimal system, so if any person knows how to correct error codes inside the computer, for that person it will be very beneficial to know the location and the details of error on the screen. So these error codes are helpful for those people who are proficient in working at the hardware level of a computer. The second use of hexadecimal codes is in the MAC addresses, which are printed on the network interface cards of devices. All the devices in the world, whether they are mobile phones or tablets or laptops, have a unique number printed on their network interface card that is called the MAC address. MAC addresses are unique for every device in the whole world. The MAC addresses comprised of 48 bits. 48 bits means that 48 divided by 8, that is equal to 6 bytes. 6 bytes means that the older MAC address is comprised of 6 bytes, 6 sets of bytes. This is the first set, this is the second set, this is the third set, this is the fourth set, this is the fifth set, and this is the sixth set. But the first three bytes represent the company's fixed MAC address. Suppose if the company is Dell, the MAC address of all Dell devices will be the same, 001422. If the company is Cisco, the first 3 bytes of MAC address will be the same for all Cisco devices, that is 004096. If the company is Intel, the first 3 bytes of all devices of Intel will have the MAC address 00A0C9. Next 3 bytes means fourth, fifth, and sixth byte are different for all devices, because these different numbers will make the device unique. The latest MAC addresses, keeping in mind the increasing demands of devices, the latest MAC addresses comprise of 64 bits. 64 bits mean that 64 bits mean that you will divide 64 by 8 to get 8. It means now the newer devices have 8 bytes at one time, because 6 bytes were too less to represent the number of devices. You can see that double N is written in 1 byte and double T is written in 1 byte, because one hexadecimal digit is so small that it can only be represented by a half byte. You can see that 2 hexadecimal digits can be accommodated in 1 byte, because one hexadecimal digit only occupies half byte. It can be clear. You can see this from this table that is given on page number 7 of your books, that one hexadecimal digit only occupies half byte. It means in 1 byte you can accommodate 2 hexadecimal digits. This is what is represented over here. Double N means 2 hexadecimal digits can be written in over here, and double D means two hexadecimal digits can be accommodated over here. The next use of hexadecimal number system is in the IP addresses. IP addresses are the addresses which are allocated to you when you get an internet connection. When you get an internet connection, the previous IP address is only comprised of 32 bits. 32 bits means 32 bits means that if you divide 32 by 8, you will get 4 bytes. The older IP addresses comprised of 4 bytes. The older IP addresses were called IPv4 because they comprised of 4 bytes. Now the newer IP addresses comprise of 128 bits. If we divide 128 by 8, we get 16 bytes. The newer, keeping in mind the increasing use of internet, the newer IP addresses comprise of 128 bits, that means 16 bytes. But the name is not IPv16, its name is IPv6. So you can see that 1 byte, 2 bytes, 3 bytes, 2 hex digits make 1 byte. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And in older IP addresses, the older convention of IP addresses is to use one colon, but the newer convention of IP addresses uses one decimal point. The next use of hexadecimal number system is in the HTML color codes, which is the language of the behind the web pages that you use. There are 6 popular colors that are being used. The RGB color scheme is being used in these web pages. Suppose if you have double F, which is the maximum value of any hexadecimal digit under red, and double zero under green, and double zero under blue, then the color will be red. All the color codes have hash sign before them. Now if you have a color that has both zeros under red and both F under green and both 0 under blue, it means the color will be green, because this is the double F is the maximum value of green, so this color will be green. And same is the case with blue color. If you have a color code that has 0 under red, and that has zeros under green, and that has both F's under blue, it means that it is the maximum value of blue. You can have smaller values over here like 80. You can have other smaller values like CF. So it depends on if the intensity of blue color that you want at any location. So these are the color schemes that are being represented by using hexadecimal. Red color occupies 1 byte, green color occupies 1 byte, and blue color occupies 1 byte. And the maximum number of shades that can be accommodated for red will be 2 raised to power 8, and maximum numbers of greens that can be accommodated at any place will also be 2 raised to power 8, and the maximum number of blues that can be accommodated at any one place will also be 2 raised to power 8, and 2 raised to power 8 is 256. So if you will multiply 256 into 256 into 256, you will get the value which is given in your book. 16777216 is the possible numbers or number of colors that can be accommodated in these 3 bytes for red, green, blue color system.